This is lecture number 24. We will be talking about mailing lists implementation in this particular lecture. In the previous lecture, I had talked about in the previous lecture the peer-to-peer mailing system. So mailing system was always one user A to another user B. So what we did was, instead of routing this thing through some SMTP server and then going to another SMTP server and then going to an IMAP server and then be accessing it, we tried to set it up peer-to-peer directly. And for this we used some other nodes which were there in mailing storage DHT network. So we use them as intermediary storage if A and B are not alive, so B can pick up. So A deposits and B picks up, and it is done in such a way that A digitally signs it, but it encrypts for the B, only B can decrypt it. So B verifies A has sent this particular message and it decrypts it. So non-repudiation and secrecy both are maintained. Here the non-repudiation and secrecy will depend on this user will not allow anybody else except A to connect and send the message. And these SMTP servers are doing verification of each other via reverse zone mapping, reverse zone verification. They are basically dependent on DNS resolution for both IP address to DNS name and DNS to IP address. So both verifications are done, and these servers are owned by same organizations. They are actually can rely on each other, and again B can retrieve the message by doing authentication to this. So this B's authentication to this and A's authentication is to this. So B's authentication is not aware to him. So it's only just passing on to somebody who is responsible for this domain. Okay. So we just replaced this whole thing. So we just replaced this whole mechanism and we want to peer-to-peer. So that's what we did in the previous lecture. But those of you who have been actually using mailing lists, so we sometimes, for example, in IIT Kanpur, so I am in electrical engineering, then I want to send a mail to all electrical engineering faculty. So one possible method is I am going to maintain my own list where I will list all email IDs of each faculty member, and my client will now read each one's email ID and will create those many copies, and these copies will be dispatched either via the conventional mailing system, this is a conventional one, or via peer-to-peer system. In peer-to-peer system, this will essentially is going to send, if there are K faculty members here, there will be K mails being sent, dispatched by him. So normally this is one possible way of doing it. There is another way. We maintain something called list server. So this is a special server or a machine. So this maintain lists. The advantage of this is that I need not, in this case, in this scenario where I am maintaining a list of my own. So every faculty member has to maintain a list of his own. So a new faculty member joins, I have to add my list here. Everybody else in the faculty member has to do it. So if somebody fails it and he would like to send a mail to all faculty, he will not be able to. Then somebody will be missed out. So people came up with the concept of list server. So in this case, a list is a separate server. We call it list server. In IIT Kanpur, we run it with a domain called list.iitk.ac.in. So this is a domain. So if you ask a DNS will always resolve this as the mail server. And of course, the MX record is also maintained for this particular domain. So MX record for this domain is also this same machine itself. Okay, and this machine is actually running like a SMTP server. So this machine also can communicate to IIT Kanpur's SMTP server. So this machine is authenticated, authorized to send mail to anybody. Okay, but it will show that mail is being sent by whom. But it is going to come with some kind of mechanisms where it will indicate that this was a mail sent to lists, and there is a list name. So normally, for example, we will have a list name where we will say EFC, and then the title will be there. Okay, what is the topic on which it has been done, and then sender will always be the original sender who has sent the mail to him. So this will essentially use that as a sender. But we can look into header that it has come from, originated from this particular mailing list server. So now the administration, so there is only one place where the whole list is maintained. We'll maintain a data structure here. So we have to remember that we are also going to do the same thing. Okay, when we will implement it in peer-to-peer mechanism. So administrator will now maintain a list. So it will maintain faculty A, faculty B, and so on. So whenever some new guy joins in, he will put some faculty new will be added to this list. Okay, and then this basically is nothing but an email ID of that person. So this will be essentially but written as faculty a@iitk.ac.in. Okay, we will also have that who all can send a mail to list. So we will say whether this guy is permitted to send or not. So there will be then settings will be there for each list, whether anyone can post on the list. So even if he is not a member here, he can still post. Okay. In fact, we use an open source called Mailman. So this is an open source list server which is available, which can be used for configuring all these mails actually. So anyone can post, only group member can post. We will also have an option that if only administrator can post, the administrator can always post actually, or there will be only selected people. It can actually specially select special people who can do it, selected people can post. So whenever a mail comes, all this logic has to be tested, and then only mail will be permitted to either to be forwarded to every member or not to be forwarded to every member. Okay, and this check has to be done here. So once if this check fails, in that case the mail will not be forwarded. Okay, so all this mailing thing will be done. Anyone means the person need not be even member of this particular group. So group members can be there, and then of course selected people even from outside, from the group of anyone can also be there in this case. So we kind of create a filter, a restriction here. Okay, we also can have for each user I can have a setting that there is going to be a digest mode, means all the mails which are dispatched to this particular group in a day will be combined and as a one single mail will be sent to the user. Okay, or is a mail basis, per mail basis. So both ways it can be done. So we have a lot of options of this kind which over the time actually has evolved and have been added to the system. Now we want the same thing to be done here, but I don't have a single server, that's a problem. Okay, and then I also don't want the list to be modifiable by anybody else except the owner. Now in this case, who is the owner? So owner in this case is the one who is owning this particular server, who is having the admin rights on this server. So the admin here is what actually controls the list. So in our case, in peer-to-peer system, when I am going to do it, we will do it in a slightly different way. So the way we handle it, we create a separate DHT layer, another DHT layer, and we call it a list servers. So any node can act as a list server, that's very important thing. So they all will form a separate DST network. So they will be in a. So now basically what is happening is anybody can create a list. So how the list will be uniquely identified. So there will be a list name which has to be there, and we have a colon as a separator, and then the user ID. So I can create my own PhD students, and then I can say this is my PhD student, so this is I am creating, so I am the owner. So this is a unique identifier for the list. Okay, so when I create this list, I need to also create a data structure regarding the configuration. So I will now put up a list of email IDs in this case. Another important thing is, because now I am actually using some third party who will be acting as a list server, only these people should be able to read the mail which are sent to this group. So even if he does this guy does some problem and wants to copy this mail to somebody else, he should not be able to read it. So we also now start using a group key. So in the earlier system which we have here, when we are using list server, we are totally dependent on the administrator, because that is controlling, we have faith on him. So in our case, there is a computer center head who actually takes care of this, or an engineer on his behalf takes care of it. And so we have, but if they does something incorrect or they do misconfiguration, you cannot stop. In our case, because the list server is not owned by me, somebody is acting as a voluntarily as a list server. So we cannot allow anybody else to read except the group member. So we need to maintain a group key. So everybody who becomes a member of this list, I need to send a group key to him. So this is done through a peer-to-peer point-to-point mail system. So I will send a mail message telling that I have created this particular thing. Okay, and this is the group key. Now remember, this particular message in peer-to-peer mail is encrypted, and the source can figure out, source can encrypt it so that only sender can get it. Okay, and of course sender will always receiver can get it, and receiver can figure out that actually who is the sender. So there is a non-repudiation, there is signatures which are there, digital signatures. So there is tampering in between that we can figure out. So this nobody else can read except the receiver, and nobody else can send except the sender. So the group key can be communicated to every user. This has to be done. If you have 10,000 guys, the moment you add somebody, you have to send a message to him, this is your group key. We also need to have a mechanism, somebody forgets the group key, a mail comes, this guy then can send a message back and wait for a group key to arrive. So every user need to maintain all the groups which he has created and all the keys which have been assigned for the encryption. It can also change the key so that everybody will have the new key. So what will happen is, this will act as now my search key. So this key is for the encryption. This is a group encryption key, I should call it. Okay, so this. So this is what is going to be my list name, unique list name, because I am because every user can actually reuse PhD. So PhD with different user is a different list. I can now actually create from here. This is my key, search key basically. So whatever is key and copy one. Remember this copy one, copy two we have been using for resilience purpose. For every key whose hash before I compute the hash, I will add a copy one, compute the hash of this, and then find out who is the root node for this one in the DST. And this root node will also now find out using the same thing, copy to hash, and this is second root node. So this guy will be now doing republishing periodically here, this guy will be republishing here. So even if a node dies off, entries are not dead, so root 2 will figure out and he will republish. So again copy 1 will get recreated. So they will essentially keep on provide a feedback to each other to maintain a stable and reliable entries inside the DST. So we are just using the same thing here. This we had used earlier also. Okay, so now this in this case, for example, if this guy now publishes a list like this PhD, so this I am actually sitting here on this device. Remember, this is a user dependent, this is not node ID dependent. So user certificate will be used in this case. So I will create this list. I will now create an entry for this. I will actually now add all my email IDs and everything. I will create a data structure. So there will be now data structure which will have the list name. And then within this list name, I will have all the email IDs of my students. So ABC, iitk.ac.in. Some students want the two email IDs to be put in. So I can put ABC, and he has got an account at Gmail also. Okay. And of course I will also can, but the important thing is that here who can transmit, who cannot transmit these permissions. Of course I can put in, but it all depends on this list server whether he actually does the control as per the permission. I can say he is permitted to post. I can say this is not permitted to post. Now this is openly available list, but this is only available to this guy, nobody else. Okay, so I have published my list here. So there are many group members which are sitting in. So the group members can also be participating in DHT. So for example, this is a group member, this is also a group member, this is also a group member, this is also a group member, and this one is also a group member. Of course I am also a group member, okay, because I am the owner of the list. So this guy want to send a message, how this will be happening. So it does not know the complete list I am managing. So whenever I am doing the updation of list, this list has to be updated in this DHT. So I am acting here as a leaf node. So I can also be participating in this DHT, that is possible. But where my list, which root node will become responsible, is not in my control. That's purely random actually. That depends on the cryptographic hash. So I will publish my list here. This list or this data structure is going to be digitally signed by me. Okay. So this has to be signed by my user ID is private key, and with my certificate you will be able to verify. Remember, any user certificate you can retrieve from the base layer, base DHT layer, that is possible. So and just let me keep this figure here. So in this case, now this guy want to send a message, what is going to happen? So this guy now sends, will find out who is the root node for this. He will actually simply create whatever is this list name, copy one, compute the hash, and then find out the root. It will go to the root. So even if this node dies off, somebody else will become the root node. So copy 2 will ensure that it actually goes to the new root node for copy 1. So my request will always be reaching there. So my request reaches here. It will look into the list now. Okay. It will look into the list. It says job. Remember, this message is encrypted with group key. So this key is being used for encryption. So nobody else can read except the group members who have individually got the keys actually. So this guy will now look into the list one by one, and it can now start dispatching the messages to everybody. Okay, so far these numbers are small, is perfect. It actually sends a copy to each one of them. Okay, so everybody will figure out this has been digitally, message has been digitally signed by it, encrypted by this key, sent to this particular group. So using that group, they will be able to decipher it. So remember, the change is if you send it to point, you can use the public key, but group key has to be distributed to everybody. That's the only way it is done. And group key of course can be modified by the owner. Okay, so this is the owner, which will this is acting as a leaf node, and this can modify the key. Okay, so this is the way now list is being done. Now the problem which we will face here is, so far the number is small, say 50 or say 100 at best. This mechanism is going to be fine. But suppose if in IIT Kanpur, for example, I have to send a mail to all at list.iitk, So everybody who is having a mail account in this domain, iitk.ac.in domain, or whoever is the member of this list, they all will get this mail. Now these number is roughly about 13,500 as of now. And as my number of students and faculty is going to grow, this may actually will become even very large. This may become 25,000 or maybe a lakh if this is a huge institute. Now how to sort out this particular matter actually? So one way is that yes, let the server be get loaded, and based on that loading, the same guy will keep on sending 1,000 copies of mails to everybody. So that could be one possibility. But we can do something better than this. What we can do is this list is all available with the list server. Okay. So list server has a list which is available, and it's an ordered list. It's say 1, 2, 3 and so on, maybe say 13,500. So what I can do is I can now partition it. So the list server, instead of sending it to everybody, will simply say that send it to only say 100 guys, not to all 10,000. And it will send a message, it will send the message as it is in text. It will send the message, but message will now, you will also have some control. It will say that you pick up 1 to 100 of the list, first 100. Okay, so maybe what happened is the first 100 guys are being picked up, and these are those people. So I can do that. So this guy can be told that you pick up from 101 to 200. This can be told that you pick up from 201 to 300. So everybody has been given an index. Okay. So this guy will be, and correspondingly will pick up 10,001 to 10,100. Okay. So this is the large number, and these further actually can be the whole space is being partitioned. So this node, if it cannot handle, it can actually further tell two nodes he can pick up from this range and tell them that you pick up from this range and from this range actually. Okay. So and some range it can directly communicate. So it can split into 3. So now each one of these nodes, when they will become responsible, they can actually fetch the list from here. Okay. The part of the list which then gets signed by the list server. So this has to sign, because the signature for the whole list and data record is actually done by the user, the owner of the list. But now this owner cannot sign it because the private key is not with the list server. So list server can only sign on its own. So it will be using node ID. There is a public key and private key for the node ID, remember. So this one is using as a node ID, the public key part. So private key can be used for signing it and sending the lists here. So these can then start dispatching the mails to everybody. This guy cannot, even if puts a wrong email ID, somehow if he is a rogue, the receivers will not be able to decode, because everybody need to have a key. And key is being distributed over time, and this need to be maintained. And before expiry, again key has to be replenished by the original creator of the mailing list. So this is how we can actually maintain very effective mailing lists for the peer-to-peer system. So this is in addition to peer-to-peer mail. This also need to be done, because this will also be a requirement to maintain huge mailing lists. So their size can become very large. But the important thing is that because of this binary tree formation and distribution, I can actually handle even very large numbers very effectively. So the depth, so this is, for example, this depth is, so this depth is 1 and this is now 2. So the depth which will be required is actually pretty small. This depth is represented by D. So every time if I am doing 100, forking being done at each depth. So if depth is D, so 100 raised power D. These will be the total number of nodes which will be which can be catered to by the mailing system. And there is a pretty large number which can actually be handled. So in fact 2 raised power 64 is such a large number that every particle on the earth can be counted into this. Okay, this is such a huge number. Okay, so every time you keep on doubling and you do it 64 times, you start with 1, 2, 2 square and so on, plus 2 raised power 63. So this will give you 2 raised power 64 actually minus 1. total value. So you can do with a geometric progression sum, and with that formula you can actually prove this comes of this particular order, and this is extremely large number actually. So we can very effectively handle the mailing list in this fashion. But remember, we need to maintain a group key. That's one additional headache which comes in, but this also provides security, and it's better than the normal listserv because you have to have faith on Computer Center. Now you don't need a faith on Computer Center. Okay, for a smaller ones you can maintain your own local list and let your own client distribute it. If it's not there, you can create a separate DST for the list servers and use them to essentially compute. Use the list server DST to essentially do all the work for you. Okay, so that's how the list server is managed.